Hi again. We are going to continue the topic of compressor, and this video is on the axial flow compressor. In the previous video, you have seen the subtopic on the overview of axial compressor. This time, you're going to go through the principles of operation as well as the construction of axial flow compressor. If we look into the principle of operation, similar to the centrifugal flow compressor, the main function of a compressor is basically to prepare the flow of air in order for it to go into the combustion chamber. So during operation, the rotor blades is turned at a high speed by the turbine so that air is continuously induced into the compressor, which is then accelerated by the rotating blades and swept rearwards onto the adjacent row of stator vanes. Obviously, the pressure will rise, which resulted to the energy imparted to the air in the rotor, which increases the air velocity. The air is then decelerated, or in other words, it is diffused in the following stator passages. So you imagine that there will be an increase and decrease of velocity when we have rotor and stators along the axial flow compressor. And this kinetic energy can be translated into pressure energy. In terms of the stator vanes, it also serves to correct the deflection given to the air by the rotor blades and to present the air at the correct angle to the next stage of rotor blades. So, last row of stator vanes usually acts as air straightener. So you want to make sure when the air from the high pressure compressor goes into the combustion chamber, it is at the right angle. This is to remove swirl from the air prior to entry into the combustion system at a reasonable axial velocity. As we can see in this right hand side chart, the changes in pressure and velocity that occur in the airflow through the compressor as shown in this figure. So you imagine the air is flowing from the left hand side to the right hand side, and it goes through a series of rotor blades and stator vane, right? From the inlet, where the air is ambient pressure, depending on the location or altitude of the engine being operated, and the pressure will then build up, whereas the velocity will have increase as well as decrease along the rotor and stator vanes. The changes are accompanied by progressive increase in air temperature. So apart from the increase of the pressure, the changes of velocity, we also need to figure in terms of the increase in air temperature as the pressure increases. So across each stage, the ratio of total pressures of outgoing air and inlet is quite small, between 1 to 1 and 1 to 2. Okay? The reason for the small pressure increment through each stage is that the rate of diffusion and the deflection angle of the blades must be limited. If not, losses due to air breakaway at the blades and subsequent blade stall are avoided. So Although the pressure ratio of each stage is small, every stage increases the exit pressure of the stage that precedes it. So that's why we have a smooth rise of pressure along the axial of the compressor. The next one is on construction, how the axial flow compressor. Mainly, axial flow compressor will have the compressor rotor. You will also have, this is the compressor rotor example, okay. We also have the stator casing. So the stator is the blades which does not rotate. The rotor is the blades which is rotating, okay. You have the lower front compressor stator casing and the upper front compressor stator casing, and you normally connect the compressor rear frame to the end of the compressor rotor, and you also have the rear compressor stator casing front of upper as well as the lower. So this is the upper and this is the lower. The construction of axial flow compressor centers around the rotor assembly and the casing. So you have the rotor assembly as well as the casing. The casing normally have the stator plates or stator vanes attached. The rotor shaft is supported in ball and roller bearings and coupled to the turbine shaft in a manner that allows for any slight variation alignment. The cylindrical assembly may consist of a number of cylindrical casings with a bolted axial joint between each stage, or the casing may be in two halves with a bolted center line joint, like we just shown just now, where we have the front casing and the rear casing, and upper casing as well as the lower casing. That's all for now. We will continue in the next video to complete the topic on compressor, and we will discuss the rotor blades and stator vanes. Keep tuned.